Welcome to the 4th edition of the International Dairy Federation Nutrition Health Symposium. My name is Laurence Rijken and I am the Director General of the IDF. Since its establishment in 1903, IDF has been a leading source of scientific and technical expertise to stakeholders across the dairy chain. Today, with a vast network of over 1,200 experts spanning 40 member countries, IDF proudly represents 74% of the global milk production. IDF mission is to help nourish the world with safe, nutritious, and sustainable dairy foods. As a trusted and enduring source of authoritative, scientific, and technical information, IDF enables the development of policies, standards, practices, and regulations that ensure the continued success of the dairy sector. For the 4th edition of this Nutrition and Health Symposium, we aim to take a deep dive in the latest scientific research on the role of dairy in food-based dietary guidelines. Food-based dietary guidelines provide the backbone for government recommendations on achieving a healthy, balanced diet, shaping nutrition, education initiatives, and food policies around the world. National guidelines are tailored to suit cultural preferences, food and nutrition security, and aim to reduce the risk of diet-related diseases. Dairy foods, including milk, yogurt, and cheese, are an integral part of these due to their significant nutritional, health, and socioeconomic contributions. As you can see in the slide, dairy foods are included in most of the established dietary guidelines worldwide and in which they are categorized. Dairy foods offer an unmatched package of essential and bioavailable nutrients, numerous functional properties, and the ability to reduce key risk factors for some of the world's most common micronutrient deficiencies and non-communicable diseases, contributing to maintaining health. Research clearly demonstrates the impact of dairy food on health that extends beyond its individual components. These are the so-called dairy matrix health effects. The effects of dairy food on human health cannot be predicted solely by their nutrient content, which seems to be especially true for the saturated fat, sodium, and natural occurring sugar content lactose. Research has consistently shown that the consumption of various forms of dairy foods has either favorable or neutral associations with cardiometabolic diseases. You can find more information in these related IDF fact sheets. Therefore, the food matrix matters. Diet quality is defined by whole foods, not individual nutrients. With that in mind, animal and plant-based foods can be seen as synergistic food sources that provide different nutritional, social, economic, and environmental benefits. We are pleased to publish today a new fact sheet where you can obtain more information on the role of dairy in these. The publication illustrates that the inclusion of dairy foods in food-based dietary guidelines ensures that population receive essential nutrients needed for optimal health throughout all life stages. There will be a dedicated presentation on the publication later in the symposium. As I mentioned, this is the 4th edition of the Nutrition Health Symposium, and you can find materials for the other past symposium on the IDF website. The previous events cover the topic of dairy matrix and how dairy relates to the topics of non-communicable diseases and health across the life course. If you are interested in knowing about science and technology on cheese, the IDF Cheese and Technology Symposium is a perfect opportunity. It will be held on June 4th to 6th in Norway, and there will be a dedicated session on the cheese matrix and nutritional aspects. The link to see the program and register is in the chat. Our annual flagship event, the IDF World Dairy Summit, will be held this year on 15th to 18th October in Paris and will involve global and industry leaders, dairy experts, scientists, technical specialists, farmers, and more to bring you the latest on the most significant issues facing the global dairy sector. IDF is publishing diverse documents on a wide variety of topics in relation to the entire dairy chain. I encourage you to visit our publication website where you will find other publications on nutrition and health. Find the link in the chat. A few examples are shown on the slide. If you would like to stay up to date with our work at IDF, sign up for our email newsletter on the IDF site or follow us on social media. A heartfelt thanks to all of you who have contributed to the organization of this webinar, and I wish you a very good event. I will now give the floor to Dr. Francesco Branca, Director of the Department of Nutrition and Food Safety at the World Health Organization. He will provide some opening remarks on the importance of the food-based dietary guidelines.
Good morning. I would like to thank the International Dairy Federation for inviting WHO to address this Nutrition and Health Symposium and to speak to you about healthy diets. Why do we need our diets to be healthy? 11 million people die every year for the consequences of not having consumed healthy diets. Many more people live years of unhealthy lives, affected by type 2 diabetes, cardiovascular disease, cancer, respiratory diseases, conditions that are disabling and creating a huge financial burden on families and public finances. Obesity is on the rise. The number of people living with obesity has now surpassed 1 billion, including many more children and adolescents than only a few years ago, not just in high-income countries, but all over the world. Unhealthy diets are missed opportunities for health and development and a failure of our food systems. We need to consume healthy diets because they promote healthy growth and development, support active lifestyles, prevent non-communicable diseases, prevent foodborne disease, and promote well-being. WHO has been constantly monitoring the science, investigating the relationships between diet and health, and has recently issued guidelines following a 10-year-long process of review. Healthy diets provide adequate nutrients at all ages and in all physiological status, provide a balanced intake of the three primary sources of energy, that is protein, fats, and carbohydrates, are composed of a diversity of foods within each food group, and moderate the intake of nutrients or foods that may harm health if consumed in excess, such as free sugars and sodium. Carbohydrates should provide the primary energy source for the body, 40 to 70%. 10 to 15% of calories consumed per day should be protein to meet the body's needs. Fats should contribute between 15 and 30% of energy and should be primarily unsaturated. No more than 10% of daily energy should come from saturated fat and no more than 1% from trans fat. Healthy diets are based on a great variety of unprocessed or minimally processed foods, include whole grains, legumes, nuts, and an abundance and variety of fruits and vegetables. Can include moderate amounts of eggs, dairy, poultry, and fish, and small amounts of red meat. Healthy diets start with breastfeeding. WHO recommends to exclusively breastfeed children for the first 6 months of life and then to continue breastfeeding until 2 years and beyond. In the last 10 years, there's been a considerable improvement in exclusive breastfeeding rates, and now 48% of infants under 6 months are exclusively breastfed. At the age of 6 months, other foods need to be introduced. Last year, WHO has released new guidelines for complementary feeding of infants and young children 6 to 23 months of age. The guidelines state that animal source foods, fruits and vegetables and nuts, pulses and seeds should be key components of energy intake. With daily consumption, dairy products including liquid animal milks, are part of a diverse diet and can contribute to nutritional adequacy. They are particularly important for non-breastfed children when other animal source foods are not available. However, flavored or sweetened milks should not be used. Healthy diets based on these principles are compatible with planetary health. We can speak about sustainable, healthy diets as there is a win-win for people's health and planet be healthy if foods are not safe. Ensuring safety of dairy product is in the interest of both consumers and producers. Consumers would enjoy better health due to improved nutritional status and reduced occurrence of foodborne illness, and producers would benefit from increased milk yield and product quality, less wastage, and increased consumers' confidence. Safety of dairy products goes all the way from the safety of animal feed to good animal husbandry, good hygiene, and use of antimicrobials and other veterinary drugs only when strictly necessary for the health of the animals. The new generation of dietary guidelines covers multiple aspects of food consumption, including nutrition, food safety, and sustainability. They also consider the cultural and social value of food and eating patterns. They contribute to public awareness and individual choices, but need to be used to shape the food environment so that those choices are feasible. They are an invaluable tool for food system transformation. Thank you.
Good morning, afternoon, or evening to everybody joining us today. My name's Julie Hendry, and I am your chair for the symposium today. The topic of this symposium, Healthy Today, Tomorrow, and in the Future, the place of dairy in dietary guidelines, is one that really excites me. In my role as a nutrition scientist at CSIRO, I've led a program of research activities looking at what Australians eat in particular and how this compares to our Australian dietary guidelines. And I've worked really closely with psychologists and agricultural researchers to design interventions to improve our diet from both a health and sustainability perspective. I work at CSIRO, and that's Australia's National Science Agency. Our research is focused on national and global challenges, and one of the biggest is improving the health and well-being of our population through healthy diets. When we consider this in the context of another global challenge in climate change, we can see why this symposium topic is so important. So before we get started and get on to the speakers, I'm going to go through some house rules for the day. If we could share the slide around that. So this event is being recorded, and you'll get a copy of the recording after the event. At the end, there's going to be a panel session with some of our fantastic presenters. So if you have any questions as we're going through, please pop them into the Q&A, and that will allow us to start with those when we get to our panel session. And I'll remind you at the end as well. You can also use the transcript option to read the subtitles for the presentations, and you can get attendance or CPD certificate upon request. Next slide, please. So we've got a fantastic lineup of speakers for you today in this symposium that will explore the complex interplay between dairy consumption, food-based dietary guidelines, and sustainable nutrition policies. Obviously, all of us interested in this area know that dietary guidelines are critical to achieving a healthy, balanced diet, to shape nutrition, education interventions, and also for food policies around the world. Nevertheless, many are being challenged to consider environmental impacts of food production and this shift towards plant-rich foods and less reliance on animal source foods. Each of our speakers today will bring a different viewpoint to this interplay between dairy consumption, our guidelines, and sustainable nutrition policies. So it's my pleasure to introduce our first speaker, Dr. Sinead McCarthy. Dr. McCarthy holds a PhD in Public Health Nutrition from the University of College Cork and is a Senior Research Officer at Teagasc in the Agricultural Food Development Authority in Ireland, where she is responsible for leading a program of research regarding consumer food behaviours. For more than 2 decades, Sinead has been involved in many areas of nutrition research with a particular focus on food and health. Her research portfolio has ranged from human nutritional physiology and public health nutrition to designing and managing national food consumption programs and consumer behaviour. She has extensive experience working on a range of national and European funded projects around food choice motivation and healthy ageing. And in the area of sustainability, Sinead is researching sustainable food consumption patterns, as well as food sustainability measures such as food waste behaviours and organic food purchasing behaviours. Sinead has published extensively and disseminated her research widely to a diverse range of audiences, from government officials through to primary school students. That's very brave, Sinead. She contributes to national food policy issues and is a committee member of the Food Safety Authority of Ireland and sits on a number of expert committees related to food systems. Her presentation today is titled Sustainable Dietary Guidelines, a Balancing Act of Population and Planetary Health. Thank you, Sinead.
Hi, my name is Sinead McCarthy from the Teagasc Food Research Centre in Dublin, Ireland, and I'd like to thank the International Dairy Federation for inviting me to present Sustainable Dietary Guidelines, a Balancing Act of Population and Planetary Health at their Nutrition and Health Symposium today. For a brief overline of the presentation, I'll start off looking at the carbon footprint of daily activities that we engage in, and then go on to look at considerations for a healthy and sustainable dietary guidelines, followed by the current dietary patterns in Ireland of Irish adults and their associated carbon footprint, and then expand this into looking at dietary guidelines and associated carbon footprint across a number of countries in Europe, and finish off with some final thoughts and considerations that you might take home with you after this event today. So when I talk about the carbon footprint of foods, I'm referring to the total amount of greenhouse gases, including carbon dioxide and methane, that's generated from the production and the consumption of our foods. So in general, plant-based foods like carrots have a low carbon footprint, and animal-based foods like red meat have a high carbon footprint. So what does a kilo of carbon footprint look like? So we're familiar with what 200 mils of milk looks like, what its nutrient composition is, and so on. But what does a kilo of carbon look like? Well, first of all, it would only feed this beautiful dog of mine, Molly, for a third of a day. Her overall carbon footprint for her diet is 3 kilos a day. We could watch maybe one episode of our favourite streaming movie or series that we're watching for about an hour, and we could also have either half a litre of milk or just over 300 grams of chocolate for this 1 kilo of carbon. The way I look at it essentially is that sitting on the sofa, watching a movie, eating a bar of chocolate with my dog is a carbon luxury, whereas drinking the glass of milk is a carbon necessity, whereby we have to get these essential nutrients into our bodies. So in terms of sustainable food-based dietary guidelines, what do they look like? Well, as you all know, it starts off with the essential nutrients that we need to consume in our diet. And for the purpose of ease of translation to the general population, we use these dietary guideline graphics. So it can be the food pyramid, as in Ireland and the United States, the plate, the pot, the clamshell. We have many different depictions, but essentially it's all the same information being conveyed, that we should have a high amount of fruit and veg in our diets. But then how do we make these diets more sustainable, and what is the sustainability aspect? And that's where the definition from the FAO of sustainable diets come in. So we now need to overlay these guidelines and make sure they're affordable, make sure any sustainable guidelines are respectful of biodiversity and ecosystems, culturally acceptable, economically fair, healthy and nutritious, and safe as a given. And how does that then translate into a new graphic that gets that balance right between sustainable diets, healthy diets, that's protective of both the population and the planet? And herein lies many difficulties. Are these low carbon diets adequate in nutrients? And that's one of the first questions to ask. One of the first set of guidelines, if you like, proposed for sustainable diets came from the Eat Lancet, with the recommendation to increase fruit and vegetables and legumes and pulses and minimise animal-sourced foods such as meat and dairy, as we can see in the picture here. But will this suit all people? Are we going to get enough nutrients by taking out or drastically reducing some of the essential food groups in our diets? And this is an output from Ursula Leonard, who's working on the SUHI project, doing her PhD. And she did a recent review on the impact of consuming an environmentally protective diet on micronutrients. And what's really interesting about Ursula's research findings is that she found that following a low carbon diet could result in low intakes of zinc, calcium, iodine, B12, A and D. And that there was a risk of inadequate intakes of zinc, calcium, vitamins A, B12 and D. And that inadequacy was likely to increase in 10 of the studies that she looked at in this review. So we need to make sure that we're still getting an adequate diet when we overlay this sustainability piece as well. The other thing to think about is that no one of us here in this room today are actual experts in sustainable diets. We might be experts in the nutritional element of sustainable diets, but sustainable diets has to take into account the entire farm to fork perspective. So we need to include experts in the area of agriculture, experts in the area of food production, because one recommendation that we make at the end of this supply chain to change a food group could have implications for the biodiversity and ecosystems at the start of the food chain. So we all need to work together and bring all of our expertise together when discussing sustainable diets. And one additional point to consider as I go through the rest of the presentation as well is that most of the emissions associated with food groups begins at the farm. So about 88% of the total emission associated with a food product has been generated before it leaves the farm gate. So any incentives or subsidies that we can put in place to help the farmer improve the environmental costs associated with food production will have the most impact. We can see here for a glass of milk, or for a litre of milk rather, there's about 2 kilos of carbon associated with the production of a litre of milk. 88% of this carbon, or 1.76 kilos of this 2 kilos, happens at the farm gate, and the remaining 0.24 kilos, or 12%, happens after the farm gate. So again, this emphasises how we can have the most impact by helping our farmers to produce food more sustainably. So moving on to the Irish diet and sustainability in the Irish population, and this is where my journey in the area of sustainable diets began. When I started to look at food intake in the Irish population and to see what our patterns of food consumption were like, and were some people following a more sustainable or a lower carbon footprint diet than others. So the outcomes of this research with my team and with John Hyland, who was the postdoc at the time, are listed here if you'd like to see further information on it. So starting with food intakes and nutrient composition, we took the food consumption database of Irish adults, or the National Adult Nutrition Survey. And if you were to have completed this survey, this is the type of food diary you would have kept for 4 days. When these were all collected using a data entry software that's underpinned with the McCann Wilson composition of foods, we generated food and nutrient analysis for the 1,500 people who took part in the survey. Then, taking this food and nutrient analysis, I applied a carbon footprint to each of the foods to try and generate the carbon footprint of the diet itself. So using the life cycle analysis, or LCA approach, where the entire carbon cost of the food from the beginning to the end is taken account of. we applied these conversion factors to the foods that were consumed. So for example, a kilo of carrots had a conversion factor of 0.5 kilos of carbon, whereas a kilo of meat had a conversion factor of approximately 35 kilos of carbon. So these conversions were applied to all of the food intake to generate a carbon-related database, and then patterns of consumption associated with the carbon footprint was looked at as opposed to the foods themselves. So first of all, the overall diet for Irish adults is about 6.5 kilos per day, and that's what we're generating through the consumption of our food. When we look at this from a carbon footprint perspective and seeing what foods contribute to the carbon footprint on the left here with the blue line, we see that the plant-based foods like your legumes, vegetables and fruit have a low carbon footprint contribution in the diet. And as we move to the right, we see that as we get into the animal-based foods or animal-derived foods, the carbon footprint starts to go up. What's also interesting is that we see the carbon footprint of savoury snacks, carbonated beverages, high-sugar snacks are all quite low. And then when we overlay this with the amount of food we consume in the red line, we can see that we're not actually eating all that much red meat, but it is making a big contribution to the carbon footprint by virtue of its high carbon footprint to begin with. What's really important to note here as well is that we don't eat individual foods. We actually eat dietary patterns, or we eat dietary patterns or a combination of foods. When you think of your breakfast you had this morning or the dinner you may have this evening, it's not one food group necessarily on your plate, but it's a pattern or a combination of foods. So we started to look at what combination of foods were people eating, and were some of these combinations more sustainable or not. So we looked at dietary patterns and emissions in Irish adults based on the carbon footprint they were generating from the foods they were consuming. And we identified 3 distinct groups. The first group we termed unsustainable, at about 25% of the population. They were distinguished by having high intakes of processed meat, savoury snacks and alcohol, and they met the fewest number of nutritional guidelines. A similar sized group at 26%, a nutritionally sustainable group. These were characterised by having high fruit and vegetable intake, high fish intake, low red meat intake and high dairy intake. They also met the most of the nutritional guidelines as well. And then the last group was nearly half of the population, and we termed this group the culturally sustainable group, following a cultural pattern of consumption that was defined by having a high red meat intake, high dairy intake and high starchy staples. Now, they met more of the nutritional guidelines compared to the unsustainable group, but they weren't as nutritionally achieving the guidelines as the nutritionally sustainable group. When we then went on to look at the carbon footprint of each of these patterns, we saw that the unsustainable group had a carbon footprint of 7.5 kilos per day. And this is a kilo higher than the population average that you might remember I showed you in the previous slide. In the nutritionally sustainable group, they had a footprint of 6.3 kilos per day. And in the culturally sustainable group that had the highest red meat intake, they had a carbon footprint of 6.2 kilos per day. So having that high red meat intake, having the high dairy intake, didn't result in a higher carbon footprint necessarily. And it was very similar to that of the nutritionally sustainable group. So it's important to look at these patterns and see which ones are more sustainable, which ones are more achievable, which ones meet that culturally appropriate diet for a population, and try and refine them so that the pattern itself is acceptable but has as low a carbon footprint as possible. This brought us on to the SUHI Guide project that I've mentioned already, and looking at some of these patterns and trends across other countries in Europe that had published their national food consumption survey data and had also linked it to a carbon footprint analysis as well. So we went on to look at the food-based dietary guideline, to what extent it was being achieved and what the implications might be for sustainability and health if the guidelines were achieved across a number of countries in Europe. So we started with the national food consumption data from a number of countries, and they were selected if they had published their data and if the carbon footprint was associated with it. And then thirdly, that there was a food-based dietary guideline available for that country. So that identified 7 countries for us to include, 7 countries from Europe, to include in this. We then reassigned the outcomes from each of these papers into the same food-based dietary guideline food groups of fruit and vegetables, starchy staples, dairy, meat, poultry, fish, and discretionary foods. When these food groups were assigned, we then calculated the changes required in food group intake to meet guidelines and what the carbon changes would be if these guidelines were followed. So here's the results, first of all, for Ireland. What we can see to begin with is that we're eating far too much discretionary foods in that red bar at the top of the graph. Somewhat too much meat, not enough dairy, somewhat too much starchy staples, and certainly not enough fruit and vegetables. We see similar trends across many of the other countries in Europe that we found data for. Again, in the UK, consuming far too much discretionary foods. And for the UK, there isn't actually a definitive dairy recommendation. So it's eat moderate amounts as opposed to 3 portions a day or something more quantitative like that. Similarly, in Sweden, high intake of discretionary foods. And again, there is no precise dairy recommendation in the Swedish dietary guidelines. And again, they're falling short as well of the fruit and veg recommendation. But that fruit and veg recommendation is higher than in other countries. Finland, again, the high discretionary foods, low starchy staples in Finland, but they do have quite a high recommendation for starchy staples. And they're just about maybe meeting their fruit and veg intakes. In France, they're somewhat below the dairy recommendation and also below their fruit and veg recommendation. Similarly, in the Netherlands, lower than recommended for dairy, lower than recommended for fruit and veg, and very high discretionary food intake again. And then finally, in Italy, we don't see as high a discretionary food intake. They're certainly not meeting their dairy guidelines. And although they have the highest fruit and veg consumption, they're not meeting their guidelines because their recommendation is much higher than any of the other countries across Europe. So when we look at each of their countries and the contribution of each of these food groups to greenhouse gas emissions, this is what we see. The amber colour in the middle of the chart represents meat, poultry and fish. And we can see for all countries, this is making the biggest contribution to greenhouse gas emissions. However, what's notable, or most notable even on this particular graph, is the contribution of discretionary foods. In the case of Ireland and the UK, it's over 30% of carbon is coming from discretionary foods. And these are the foods that are least necessary from a nutritional perspective in the diet. What we're also seeing in the case of Italy, because of their high fruit and veg consumption, we're seeing quite a high contribution from fruit and veg to the greenhouse gas emissions, being the second biggest contributor in the Italian consumption patterns. So if we were to align our intakes with the actual guidelines, what would this look like from a carbon perspective? So here we look at, first of all, the foods that we pretty much need to increase to comply with guidelines. So we would need to increase fruit and vegetables, which for each of the 3 countries, Ireland, Netherlands and Italy, would result in a slight increase in carbon. Similarly, with the whole meal and cereal category, we needed a slight decrease in Ireland and a small increase in the Netherlands and Italy, which would result in an increase in carbon in these 2 countries. And similarly, all 3 countries didn't meet their guideline for dairy, so we would see an increase in carbon associated with dairy if we were to align with our guidelines for these 3 countries. Then we can see that this increase in carbon associated with aligning with the first 3 guidelines can be offset by aligning with the meat guidelines, and reducing our meat intake will result in quite a significant reduction in carbon associated with these food groups. But similarly, discretionary foods, again, which are not necessary in the diet, if we even have our discretionary foods, so this isn't removing it entirely from our consumption patterns, but even have their intake, this is the improvement we can see in the carbon footprint. And overall, we see quite a dramatic improvement in total carbon footprint in Ireland. We would see a small improvement in carbon footprint in the Netherlands. But if Italy is totally to comply with their carbon footprint because of the increase in dairy we would see a slight increase in carbon footprint in the Italian diet. So obviously the patterns of consumption, the extent to which we currently comply or not with our dietary guidelines will result in different impacts of complying with guidelines. So some final considerations to start wrapping up this presentation. It's really important to focus on every food group in terms of its contribution to health and sustainability. To date, we see very much the discourse around sustainable diets focusing on animal-derived foods and to minimise or reduce these foods. And we've seen earlier that we don't necessarily meet the guidelines for all of these foods, and possibly if they were to be removed, some of the micronutrient inadequacies might come to light. Discretionary foods are not actually in the guidelines and make a significant contribution to carbon footprint, and in some cases similar to that of the animal-based foods. So a focus needs to be put on the consumption of these foods to reduce these foods, not only from a carbon footprint perspective, but it would have knock-on public health positive implications also. The definition or defining of the guidelines for each of the food groups could do with more clarity and being more quantitative in nature. So rather than being vague and saying eat dairy in moderation, perhaps the guidelines should be more specific in terms of the amount of dairy, the number of portions of particular dairy foods, and this might help increase adherence to the guidelines as well. Fruit and vegetables need to increase across all countries, and it will result in an increase in greenhouse gas emissions, but it can be offset by reductions in meat or especially in discretionary foods. Achieving the guidelines will have small changes in greenhouse gas emissions, some positive, some negative. So we very much need to focus on the efficiency of food production. As we were seeing earlier on, 88% of the emissions come from the farm production. So bigger gains might be achieved through efficient and sustainable production of foods to meet population requirements. So ultimately, the foods that we consume will have a lower carbon footprint as we consume them. We need to think about data inputs and the reliability of the data that we're using when we're communicating some of this information as well. And I want to just compare here the nutritional content of foods using different data sources versus the carbon footprint of food using different data sources. So if we look at 100 mils of milk and we use either the USDA source of nutrient composition or McCann-Whiddison source of nutrient composition, we'll see they are very, very similar. So the calories, the protein, the calcium per 100 mils of milk are pretty much exactly the same. This is not the case when we look at carbon footprint. So when we take the life cycle analysis, and that includes everything from farm to fork to disposal of a particular food, we see two very different conversion factors for dairy depending on the source that's used. And what this means is using the Clark conversion factor, a 500 ml glass of milk will have 0.7 kilos of CO2, or using the Shielbeck conversion factor, a glass of milk would have 4.2 kilos of CO2. So it's important to interpret findings in terms of the carbon footprint conversion factor that was used. In addition, we should be looking at more than one metric of environmental impact. So for example, a recent review paper completed by Clarissa Leyden, published last year, showed that we need to look at other indicators than just carbon footprint to get a better assessment of the diet, because water footprint is quite different from carbon footprint, and we see that fruit and veg will have a high water footprint, as does rice as well. So these are other implications and considerations that we need to And finally, I just want to tell you a little bit more about the SUHI guide. To very much watch this space. We have very interesting findings coming out from a dietary intervention study where participants were put on a low carbon diet versus a healthy eating diet for 12 weeks, and we're looking at all the outcomes of that diet. So this is a project going on in collaboration with ourselves and Teagasc, University College Dublin, University College Cork, and Queen's University in Belfast, and it has been funded by the Department of Agriculture in the Republic of Ireland and the Agriculture, Environment and Rural Affairs in Northern Ireland. I'd like to thank you very much for listening. And just to finish off, here are some of the publications I might have mentioned earlier in the presentation that you might find of use. Thank you very much, and I look forward to discussing some of these findings later with you in the discussion area.
Wow, thanks, Sinead. Really, really interesting presentation. Yeah, we've done some similar work here in Australia, and I can tell you that Australians don't eat enough dairy, and we consume 2 to 3 times more discretionary foods than what's recommended in our dietary guidelines. So same, just different hemisphere. And discretionary foods contribute significantly to the environmental impacts of our diets here down under, purely based on how much we eat. So starting our journey around the world and moving south to South Africa, our next speaker is Professor Corinna Walsh. Corinna is a South African National Research Foundation rated professor in the Department of Nutrition and Dietetics at the University of the Free State in South Africa. Her research interests include developmental origins of health and disease, HIV and malnutrition, with a specific focus on nutritional health, food security, and transitions from traditional to Western diets and how these can impact on our health outcomes. She has published widely and has supervised more than 50 masters and doctoral students. Corinna served on the board of the South African Medical Research Council for 6 years and is the past president of the Nutrition Society of South Africa. Today, we are fortunate to have Corinna speaking to us about how dietary recommendations in South Africa compare to dietary consumption data. Thank you, Corinna.
Good morning, good afternoon, good evening, depending where in the world you are today. Thank you so much for the invitation to present today at the IDF Nutrition and Health Symposium. The title of my presentation is Dietary Recommendations in South Africa versus Consumption Data. South Africa is characterized by diverse culinary practices, socio-economic disparities, and health challenges. Understanding how dietary recommendations intersect with the realities of consumption is relevant to inform policy and to promote public health. In South Africa, the burden of disease is mostly attributable to non-communicable diseases at 50.9%, looking at the Stats South Africa 2018 data. Communicable diseases account for 16.6% of the burden of disease, injuries 11.9%, and ill-defined reasons 13.5%. The primary goal of food-based dietary guidelines is to assist the public in selecting healthy diets, which are defined as diets that fulfill all nutrient requirements and guard against diet-related NCDs. The South African Food-Based Dietary Guidelines were first published in 2003, and a revised version was published in 2012. These guidelines were developed by the Nutrition Society of South Africa in partnership with the National Department of Health, the Medical Research Council, academics, food producer organizations, and United Nations agencies. They were adopted by the National Department of Health and are currently used for nutrition education in South Africa. The 2012 guidelines were based on this publication, looking at the burden of disease or nutrition-related health outcomes in South Africa. At this time, high blood pressure, excess body weight, high cholesterol, diabetes, low fruit and vegetable intake, childhood and maternal undernutrition, vitamin A deficiency, and iron deficiency anemia were identified as the primary health outcomes that needed to be addressed. Risk factors that are indirectly related to nutrition include physical inactivity and unsafe water, sanitation and hygiene. And the guidelines take the unsafe water, sanitation and hygiene into account as well. So the South African food-based dietary guidelines are as follows. Firstly, eat a variety of foods. Be active. Make starchy foods part of most meals. Eat plenty of vegetables and fruit daily. Eat dry beans, split peas, lentils and soya regularly. Have milk, mass and yogurt every day. Fish, chicken, lean meat or eggs can be eaten daily. Drink lots of clean, safe water. use fat sparingly and choose vegetable oils rather than hard fats, use sugar and foods and drinks high in sugar sparingly, and use salt and food high in salt sparingly. For the purpose of this presentation, I'm going to focus on the guideline, have milk, mass or yogurt every day. A food guide has also been developed in collaboration with the FAO to support the revised food-based dietary guideline messages. The food guide displays 7 food groups to be eaten regularly, and they are indicated on the slide. It shows food groupings as well, composed of local and affordable foods that are necessary for healthy eating. And the size of each food group segment reflects the volume the group should contribute to the total daily diet. So in terms of the guideline, have milk, mass or yogurt every day. This guideline promotes the intake of milk, either fresh or powdered, and the traditional fermented milk product Mass, also known as Massey in South Africa, as well as unsweetened yogurt to prevent an increase in the intake of saturated fatty acids, sodium and sugar. Massey is originally prepared by storing unpasteurized whole cow's milk in containers that are seeded with a microbial inoculum for fermentation. Massey is also widely commercially available in South Africa. Cheese is not included in the guidelines at present, and cottage cheese was also not included to avoid confusion about why some, but not all cheeses may replace milk, mass or yogurt in the diet. Reasons for including this guideline include that milk and dairy products are excellent sources of several micronutrients. They are relatively low in sodium and high in potassium and calcium. Milk is a good source of high-quality protein with essential amino acids. Milk can also be used to complement foods with lysine-deficient protein, such as maize and wheat, which are staple foods in South Africa. Then the bioactive peptides, specific fatty acids, the low pH of fermented milk, and the low sodium to potassium ratio of dairy foods is another reason why this guideline is included. Another reason why milk, mass or yogurt can be included in the diet is that it protects against metabolic syndrome and non-communicable diseases in a variety of ways. It's not only the nutrients in milk that protect, but the whole foods themselves, as well as the bioactive compounds and other properties in dairy foods. The EAR for calcium were first published in 2011. Before that, calcium requirements were based on an adequate intake. So if we take on average 1,000 milligrams of calcium, which is somewhere between the EAR and the RDA, and about 2,000 milligrams of potassium per day as appropriate for women aged 19 to 50 and men up to the age of 70 years, then about 400 to 500 mils of low-fat milk per day is recommended and will provide about half of the EAR for calcium, 30 to 38% of the recommendation for potassium, and only 9.2 to 11.5% of the maximum 2 gram per day recommendation for sodium intake to protect against hypertension. The potassium in milk is especially important in populations that do not meet vegetable and fruit intake requirements, and this is commonly seen in South Africa. Right, now we move on to the South African nutrient and food consumption data. So as a background, in 1997, Prof. Esty Foster and colleagues published a set of comprehensive reference tables that were based on a review of the literature from 1975 to 1996 about the nutritional status of South Africans. This review identified inadequate diet and high levels of malnutrition as critical in South Africa. Since then, a number of South African national surveys and various regional studies have provided much needed information on the health and nutritional status of South Africans, but have not included a comprehensive assessment of the dietary intake of South Africans. And therefore, a need was identified for the South African National Dietary Intake Survey. Now, this survey was conducted in 2022 by a consortium of universities under the leadership of Prof. Rina Swart from the University of the Western Cape, and the report is due to be published soon after it has been approved by the National Department of Health, but this product is not available yet. So one of the first deliverables for the National Dietary Intake Survey was that a follow-up review to the review of Foster should be completed. So the aim was to conduct a comprehensive, systematic review of the available literature published from 1997 to 2019 on the dietary intakes and nutritional status that included diet, biochemical indicators, and anthropometry of South African adults. The reason for the desktop review was to determine the extent of South African research on nutritional status, then to extract and summarize the data for research intervention and policy planning of all the studies that were included. Also to determine representation of the South African population, the methods that were used in the studies, and cut points that were applied. The review reports on trends, either positive or negative trends over the period, and helped to inform the methodology that was applied for the National Dietary Intake Survey in 2022. I'm going to focus now on the food consumption data related to dairy intake. If we look at this schematic representation of global per capita milk consumption, you can see that the orange line at the bottom indicates intake for Africa and that it is much lower than intake in other continents or other areas. In all groups, the frequent intake of milk and milk products was relatively low, except in a small number of subgroups, such as those who lived on farms and in upper-class urban areas. When milk was consumed, it's usually in small amounts, such as in tea and coffee. The consumption of the cultured milk on Massey was reported in a number of studies, especially those amongst Black Africans. And the low milk, fruit and vegetable intake that was common in most of the studies included in the desktop review agrees with the low calcium and potassium intakes that are reported for most adults. Now, when looking at nutrient intake, there are a number of limitations associated with the assessment and presentation of data related to nutrient adequacy, and this made it impossible to make valid conclusions about the adequacy of energy and nutrient intakes from the data in the desktop review. Most publications report on mean or median intakes without looking at categories. Ideally, the percentage of people in the group with intakes less than the EER for energy or the EAR for the macronutrients is necessary to make sense of the findings. Then two standards were used to evaluate adequacy, including the 1989 RDA and the newer diet reference intakes. A wide variety of cut points were applied in the studies to evaluate adequacy, including the percentage of participants with intakes below the RDA or the percentage with intakes below 67% of the RDA or the EAR. Now, in terms of calcium intake, a number of studies did evaluate intake of calcium, and you can see from this slide I've indicated the EAR for men as well as the over 70 years and women above 50 years, and then the EAR for men from 31 to 70 years and women from 19 to 50 years. And in all cases, the intakes are lower than the recommendations. So we've separated them for urban men urban women and rural men and rural women. And if you look where they cluster, generally intakes were lower in rural compared to urban dwellers. So in conclusion, dairy intake is fundamental to the health of people. In South Africa, dairy consumption is, however, largely inadequate. So food-based dietary guidelines are based on the burden of disease and the requirements for health of a population. But the promotion of the dairy guideline is essential through targeted interventions such as fortification and including milk and dairy products in feeding programs. Thank you again for the opportunity to present at this event, and I hope that you will enjoy the rest of the program. I'm so sorry that I'm not available for the question and answer session, but I trust that it will be an engaging discussion. Thank you very much.
Thank you, Corinna. And yeah, sorry you can't join us as well for the panel session later on. To follow Corinna, I'd like to introduce Dr. Stephan van Vliet. Stephan is a nutrition scientist with metabolomics expertise in the Center for Human Nutrition Studies at Utah State University. He earned his PhD in kinesiology as an Aspen Fellow from the University of Illinois and received training at the Washington University and Duke University School of Medicine as well. Stephan's research is performed at the nexus of agricultural and human health. He routinely collaborates with farmers, ecologists, and agricultural scientists to study critical linkages between sustainable agriculture, the nutrition density of foods, and human health. His work has been published in the American Journal of Clinical Nutrition, Scientific Reports, the Journal of Nutrition, and the Journal of Physiology. It's a pleasure to introduce Stephan, whose presentation is titled Achieving Dietary Adequacy and Sustainability Through the Complementary Nature of Animal and Plant-Sourced Foods. Thank you, Stephan.
Hi everyone, it's good to see you, and thank you so much for attending the webinar. My section is entitled Achieving Dietary Adequacy and Sustainability Through the Complementary Nature of Animal and Plant-Sourced Foods. So my name is Stephan van Vliet, and I'm an assistant professor of nutrition and the director of the Center for Human Nutrition Studies at Utah State University. My lab's research interest is really focused on working at the nexus of agriculture and human nutrition. Oftentimes, we're really interested in how different farming systems, and specifically more sustainable farming systems and food production systems, impact the nutritional quality, either for crops for direct human consumption, depicted here as carrots or blueberries, or feed crops for animals that produce meat and milk, and then look at its impact on human health. So oftentimes we also perform randomized controlled trials on the foods that we study to see if foods that are produced in more sustainable ways that have the potential to improve the nutrient density can also improve human health. What I want to talk to you about today is, as I mentioned, the complementary nature of animal and plant-sourced foods and how different production systems potentially impact that, and whether more sustainable production systems can actually also impact the nutritional quality of food. Now, why is that important? Because there's a widespread global micronutrient deficiency. Worldwide, 1.6 billion pre-school-age children and females of reproductive age are deficient in one or more vitamins and minerals, with iron and zinc being very common. And here you can see that worldwide this is the case. Specifically, the prevalence is higher in sub-Saharan Africa as well as South Asia. But as you can see here, even in high-income nations, there's typically some sort of deficiency. So if we look at it here on the widespread global micronutrient deficiency, and this is work by Passarelli et al. That was published in the American Journal of Clinical Nutrition. Now, what the authors did here was they looked at various countries. Here, for instance, depicted here is the USA. As you can see here, this is 14% of females are not meeting the EAR for copper. There's also deficiencies in zinc, vitamin B6, and vitamin A. The Netherlands, where I'm from, we can also see that there is micronutrient deficiencies, specifically, or inadequacies, I should say, specifically amongst females. And as we go more towards developing nations, in this case Brazil or India, Bangladesh, we see that micronutrient deficiencies are very, very prevalent, which results in a need to improve this. This is also oftentimes referred to as hidden hunger. Now, this is not just a problem of low to middle income countries. If we look at micronutrient deficiency among US women aged 15 to 49 years old, we see that at least 30% of women in the US has at least one micronutrient deficiency, with iron deficiency being most common. And iron deficiency has actually been on the rise in the US, perhaps, or what we believe due to or papers suggest due to poor quality diets, rich in ultra-processed foods, as well as lower intakes of red meat and other iron-rich foods such as beans and legumes. If we look at this work from Nelson, we see that we certainly don't have a carbohydrate deficiency. We, in some cases, have a protein deficiency, but micronutrient deficiencies are very common. Here we can see, so more red means a greater deficiency. Iron, as mentioned, being very common. Vitamin D, we spend most of our time living indoors, common. Vitamin A, folate, zinc, as well as vitamin E and vitamin B12. Now, in the next part of my presentation, I'll talk to you a little bit about the aspect of diet quality and also the importance that we focus really on sort of the complementary nature of animal and plant-sourced foods. Now, if we look at these common deficiencies of vitamin A and folate, typically they're found in high quantities in plant foods, specifically vitamin A and as well as folate, which is rich in dark green leafy vegetables. Iron, zinc, B12, vitamin D are higher or exclusively found in animal-sourced foods. Oftentimes, iron and zinc have higher bioavailability. Calcium and vitamin A, or I should say beta-carotene, can be met with a combination of animal and plant-sourced foods. So this highlights the initial synergy in animal and plant-sourced foods, which can make complementary contributions to diet quality. Now, this is work from Taibio and Flaminia Ortenzi, which was published in 2021. And what they did, they looked at what are these commonly lacking nutrients in global diets, which we saw on the previous slides, specifically focusing on vitamin A, B12, calcium, iron, and zinc. What we can see here that amongst the most nutrient-dense foods, to fill those nutrients gaps or the micronutrient deficiencies we're often referred to as hidden hunger, hidden hunger being that maybe adequate caloric intake, adequate protein intake, but insufficient micronutrient intake. We can see here that animal-sourced foods such as liver, spleen, small dried fish, dark green leafy vegetables, as well as bivalve and crustaceans, which are shellfish, also goat, beef, eggs, and cow's milk, and vitamin A-rich fruits and vegetables are amongst the most nutrient-dense foods to meet those sources. Oftentimes, these are not consumed, especially in developing nations, and also in the US, we have low intakes of specifically dark green leafy vegetables. But as you can see here, the nutrient density of these sources are very high and can help fill these micronutrient deficiencies. Especially when, if we look at it, you get a lot of these micronutrients for low amounts of calories, as well as low amounts of grams, so meaning that they're very nutrient dense. But after discussion, and then we'll go into it a little bit in the next few slides, are the environmental impacts of these. We see on the previous slide that beef and liver are very much nutrient dense, as well as crustaceans. Now, if we look at the greenhouse gas emissions, which is oftentimes a metric that is now focused upon when looking at environmental impacts, we see that they also have amongst the highest environmental impacts when this is explained per kilogram food. So 1 kilogram of beef, or I should say the greenhouse gas emissions here is per kilogram food. So a kilogram of beef would have higher emissions than, for instance, a kilogram of pulses or other foods. Here we can see, for instance, that eggs are 12. But then if you look at this per micronutrient, per priority micronutrient, and you explain, or I should say, express the greenhouse gas emissions per micronutrient as opposed to per kilogram food or per kilocalorie, we see that eggs actually are not, don't have as high greenhouse gas emissions. So the estimated environmental impacts depends on the nutritional metric that's used. And in this case, I'm trying to make the case that we should take into account not just kilograms of food, but we need to take into account these micronutrients that people are oftentimes deficient in when we make these decisions on which foods we should promote and within diets. Now, for instance, here we see that cow's milk has a higher greenhouse gas emission than soy milk. But when we actually look at the priority micronutrients being B9, B12, vitamin A, calcium, zinc, and iron, we see that they're very close to each other. Liver being amongst the top 4 now falls to number 23. So this again illustrates the nuance of looking at micronutrients when we look at greenhouse gas emissions. I also want to highlight is that historically we looked at typically protein, and we still do that. There's a hyper focus on protein, but we really need to move beyond protein and consider the entire food matrix. This is from work that we published in 2021, where we make the case that only 30 nutrients routinely appear on nutrition food panels. The USDA food composition database tracks only a small amount of these nutrients. But food sources, they probably contain about 30,000 compounds that are capable of impacting human health. And as we can see here, its impact of the food metabolome on the human metabolome and the nutrigenome is something that is certainly of more interest nowadays, as we try to understand the complexity of foods rather than classifying foods simply as protein, which is depicted here in the case of a soybean or beef. While both provide protein, their micronutrient profile is also very much different. And this is something that is, of course, important to consider, especially moving forward when we move away from this simplification of protein or fat and actually call them food. Because foods contain a variety of micronutrients. After this paper that we published in 2021, later on that year, we published a paper that really inspired that work. Was we were very interested in, if we look, for instance, at if you can see here, ground beef and plant-based meat. Ground beef here on the left has roughly has a similar nutrition facts panel as plant-based meat. We can see here 19 grams of protein, 23 grams of protein. You can see roughly similar amounts of micronutrients. But if we look at this on a broader level, beyond just the micronutrients that are displayed here and the protein levels, which are fairly similar, the fat is matched, the protein is matched, various of the key vitamins and minerals are matched. We can see that if we study the whole food matrix and looking at, in this case, 190 compounds, many of which have nutritional value to us, we see that they were 90% different. And 30% of nutrients were not found in either source. And we found important differences in individual amino acids, in fatty acids, in phytochemicals and other secondary nutrients that are exclusively found in animal source foods or in plant source foods, again highlighting that they are very much different, and you could argue that both have an important role in our diet because they provide very much different nutritional profiles. Now, if we look at nutrients found more readily in animal-sourced foods, it's the only dietary source of intrinsic retinol, which is true vitamin A. It's also the source of heme iron, vitamin B12, and vitamin D. If we look at it here, highly bioavailable zinc and iron. And I do want to highlight is that plant foods do contribute. And what's actually really interesting about if you look at data on this, is that actually consuming beans with beef actually improves the iron uptake of the beans because of what is called the meat factor. We don't exactly know what it is, but it's probably things such as carnitines and choline and other factors within the animal source foods that I can actually make iron from plant source foods also more bioavailable. Also the main source of DHA and EPA. And also unique, potentially beneficial compounds that, which were many of the compounds that we studied in this prior slide, comparing a plant-based meat alternative and beef, which were both meant for protein. But if we looked at the individual amino acid profile, we saw that there were differences in creatine, anserine, taurine, cysteamine, 4-hydroxyproline, carnosine, and the list goes on. While these may not resonate initially with the consumer, we do know that these compounds such as taurine and creatine and anserine play a key role in metabolism and in our health, for instance, by impacting cognitive function. There's been a lot of work done on taurine and anserine and creatine in that regard. What we also see is that, and we'll talk about it a little bit in the end, that when animals are fed diverse mixtures of feed or plants, they're actually enriched in certain antioxidants as well that are otherwise not readily picked up by humans. So this is another way of getting phytochemicals within our diet that are actually already pre-processed into a mammalian form, similar to way we would get it. So if we look at bioavailability here, vitamin A of an animal sourced food up to a proportion of plant food, 12 times more bioavailable. Iron also roughly double the bioavailability, and zinc also about 1.5 times higher bioavailability in ruminant meat versus pulses. Doesn't mean that iron and zinc cannot be obtained from pulses. They're very important sources, but when consumed in conjunction with animal source foods, they can actually be improved. If we look at it on the other side, more or other nutrients are more readily found in plant-sourced foods. Beta-carotene, a precursor to vitamin A, and then other carotenoids with antioxidant activity. Dark green leafy vegetables, as saw earlier on in the slides, amongst the most nutrient-dense foods, not consumed enough within the diets globally, and also in the US. Nuts and seeds, rich in alpha and gamma tocopherol, compounds with vitamin E activity. Fruits and vegetables, they're rich in phytochemicals, richer than animal source foods, but as mentioned, we can get some unique compounds from animal source foods as well when animals graze on diverse mixtures of plants. But phytochemicals, these are antioxidants in layman's terms. They can help protect us from chronic metabolic disease. They're picked up through fruits and vegetables, and especially consuming a wide variety of them. In that regard, the plant kingdom probably contains 50 to 100,000 of these phytochemicals, and then they're broadly classified as being anti-inflammatory, antioxidant, eventually reduce the risk of cancer, or diets high in these phytochemicals are associated with reduced rates of cancer, as well as having lipid metabolism improving properties. And oftentimes there's this synergy that we see. AGEs or ALEs, these are advanced glycation or lipoxidation end products. They can be pro-inflammatory within our bodies, but they can be, for instance, generated when we heat or grill meat. But if we marinate the meat or eat it with a bunch of plant foods, we actually see that there's quite a reduction in these potentially harmful compounds. On the other hand, zinc and iron intake from plants is increased when we eat this with animal sourced foods. Now, certainly what we see in the field is that there is this great concern about the environmental impacts of food systems. But what the discussion is about is that what is the best solution? If we look at, for instance, at the Eat Lancet diet, the suggestion is that we consume only 10% from animal source foods and 90% from plant source foods. On the other hand, the IPCC reports that routinely reports on the impact of food production on environment, as well as some impact on our human health is slightly considered there. They see more of a role for more integrated crop livestock systems or agroecological systems. So a little bit of a bigger role for animal sourced foods, but particularly when we integrate them and do a better job at nutrient cycling. For instance, if we look at the Eat Lancet Planetary Health Diet, and this is again work from Ty Beal, published in 2023, there is some concern about the low intakes of calories from animal source foods. Now, certainly, when one eats a very nutrient-dense diet, one can meet a lot of the micronutrients through plant foods, but in more of a real-world scenario, there are some concerns about this, and one thing that's often not taken into account is the differences in bioavailability, which we talked about. Another concern might be the high intakes of phytate, which bind a lot of the minerals such as zinc and iron, and these are exactly the ones that we're deficient in. Now, this is painting with broad strokes, but if you look at it here, again, work from the GAIN group highlights that about 20 to 30%, and mind you, this is painting with very broad strokes, but 20 to 30% of calories from minimally processed animal source foods can help close a lot of these gaps in nutrient intakes, and certainly having iron and zinc-rich pulses and beans and nuts can also help, of course. So, but about 20 to 30% of calories from minimally processed animal source foods appears to be enough to close various micronutrient gaps across the world. Now, one may ask, why do we see these micronutrient deficiencies also increasing in high-income nations? Well, another major elephant in the room that is likely contribute to micronutrient deficiencies is the poor diet quality we're currently consuming. And we even see ultra-processed foods being increased globally as countries become wealthier. But if you look at, for instance, here in the US, we consume about 2/3 of our diets from ultra-processed foods. And higher percentage of ultra-processed foods in the diet is also associated with lower intakes of protein, fiber, as well as vitamin A, C, D, and E, potassium, and calcium, which various of which are nutrients of concern. So our diet quality is also deteriorating, and due to a lack of intake of minimally processed animal and plant source foods, such as beans, legumes, dark green leafy vegetables, vitamin A-rich fruits and vegetables, as well as, for instance, shellfish and organ meats, which are not commonly consumed anymore in the diet. And instead, diets are rich in ultra-processed foods. So if we look at this then on sort of a bigger picture level, is that we really, I think, have to work together, bringing together ecologists, soil scientists, people that are more in population health, also social scientists, to really think of this as sort of in a holistic manner. And a lot of the concerns about the environmental impact of food production, particularly animal source food production. But this can obviously, as we noticed, can have unintended consequences on micronutrient adequacy. So are there ways in which we can produce foods that are more environmentally friendly and that also perhaps more nutritious? This is from work that we published in 2021, and we wrote about agroecology, and agroecology also mentioned in various reports, such as by the IPCC, about the path forward for sustainable food production, and also the US government supporting this through climate smart agriculture. Now, one sense I'd like to highlight from the review that we wrote is that, and this is always interesting, because if you go outside, you don't see one herbivore, you also don't see one plant, because nature has introduced great biodiversity into ecosystems, but humans continue to simplify these production systems to single species of animals and crop and separate production systems that require considerable external inputs. And while during the Green Revolution after World War II, that made sense to alleviate food shortages and produce a lot of foods in specialized manners, we do now know that these have also unintended consequences on our environment, and potentially also have watered down the micronutrient density of our foods. If we look at crop data from in the 40s or 50s, and there have been various studies done on this versus crops now, we see that many of the micronutrients, such as iron and zinc, have been reduced with 20 to 30%. So again, that plays into this effect of micronutrient deficiencies. Part of this could be due to the way we produce it, also due to cultivars. But highlighted in the left here, you see current production systems, and whereas more biodiverse systems can better cycle nutrients and require less external input. So can we keep this efficiency, but can we produce things that are more environmentally friendly? Because if you look at here the FAO, the Food and Agriculture Organization by the UN. We see that simplified systems may be productive in the short run, but they make it difficult for food systems to recycle nutrients and be sustainable in the long run. And as mentioned in the report, improving efficiency and use of resources, conserving, protecting, enhancing natural ecosystems, protecting and improving rural livelihood, equity and social well-being is also certainly a part of this. Access to healthy, nutritious foods, enhancing the resilience of people, communities, and ecosystems, and finally promoting good governance of both natural and human systems. And here, this is I want to jump into a little bit, because I think thinking of these as two separate entities, natural and human systems, I think is sort of flawed to begin with, and maybe got us into the situation where we have to rethink food production and seeing agriculture, nature, and humans as sort of one entity rather than three separate entities. So linking soil, plant, animal, and human health is what agroecology is about, and this is highlighting that various of the challenges that we have, but then also various of the improvements that can potentially be made by having more agroecological production systems, which oftentimes results in greater crop diversity, returning nutrients back into the land, making sure that there's nutrient retention, that carbon is being sequestered, that the farm has also financial resilience, that animal health and welfare is improved, that rural community health is improved. And I really like this figure in that regard by Costa et al. That sort of looks at this in like a conventional system. We have nature or forest, we have crop production, and we have animals, all separated. What if we are able to do a better job at integrating this? Can we produce food that way? I mean, obviously this would have to be rethinking it, and we may not be able to just simply, put our cattle or dairy cows in a forest and milk it that way. But can we take some things away from this, and can we maybe make some incremental improvements over time? But mind you, this is certainly a lot of this is the norm in if you go into sort of non-Western westernized nations, which are highly specific, but the majority of our food is oftentimes produced in these multi or integrated systems. One thing that we've also been studying is that, well, if we have more biodiverse feed crops, let's say in the case of a dairy cow, you feed a wider diversity of feed crops, maybe several cover crops, can this result in enhanced micronutrient or nutrient density? And what we've seen so far is that when plant species are grown on nutrient-rich soils or pastures, we typically see the nutrient density of meat and milk being increased. Other things that are very much of interest and that we've seen some good effects from is, for instance, feeding agri-waste products. And here you can see, for instance, the lemon and pomegranate byproducts that are being used for feed in a central San Joaquin Valley dairy farm. So, which otherwise may go into a landfill. So if we can provide these to animals, in this case, in a dairy system, can we then improve also? Is this a way of improving sustainability? Yes. And we will also see that this increases the nutrient density of the meat and milk, higher amounts of micronutrients, higher amounts of also these phenolics, particularly coming from something such as pomegranate, right? Which if we drink it, it increases the antioxidants. Well, it does the same thing for an animal when it eats some of the byproduct as part of the feed. So with that, I'd like to conclude. Micronutrient inadequacies are widespread globally. High-income nations, poor diet quality. Developing nations, low dietary diversity, including low animal source food intake. Plant and animal source foods can be used in complementary and synergistic ways. Some nutrients exclusively found in animal source foods, DHA, EPA, zinc, heme iron, retinol, more bioavailable or exclusively found. vitamin A, K1, high levels of phytochemical antioxidants found in plant-sourced foods. And there's a real danger in simplifying foods to protein and fat and focusing on only a handful of micronutrients or thinking of these things purely as in calories or protein, because we have, as mentioned, micronutrient deficiencies. And another part to improve this also, because a lot of these concerns come from environment, sustainability, food production, is focus on agroecology and improving diet quality. A greater shift to minimally processed plant-sourced foods with some animal-sourced foods that are produced in more agroecological ways. And with that, I like to end my talk and thank you so much for your time. I look forward to the discussion section later.
Thank you, Stephan. Really interesting presentation, helping us to sort of think through that intersection between nutrient density, crop quality, food production systems, animal health, human health. So just a reminder for everybody online, if you do have questions and would like them to be answered by the panel later, please pop them in the Q&A, and we will get onto those shortly after a couple more speakers. Our next speaker is Dr. Natalie Ahlborn from Massey University, New Zealand, just across the Tasman Sea from me here in Australia. Natalie is a postdoctoral researcher at the Sustainable Nutrition Initiative, hosted by Reddit Institute in New Zealand, where she is interested in protein and amino acid nutrition and metabolism. She's currently working on various projects involving preclinical and clinical studies. Natalie carried out her PhD with the Reddit Institute and Ag Research, where she investigated the influence of processing and ruminant species on protein digestion and small intestinal amino acid absorption in humans. Natalie is speaking to us today about micronutrient bioavailability being really important consideration for the evaluation of milk as a source of nutrition. Thanks, Natalie.
Hi everyone, and thank you all for coming along. I'm Natalie, a research officer for the Sustainable Nutrition Initiative. We're based at the Reddit Institute in New Zealand, and I'm excited to be discussing some of the considerations around micronutrient bioavailability with you, particularly in the context of milk and from a global nutrition perspective. What we'll cover today includes future food system micronutrient demands. We'll look at the current positioning of milk in the global micronutrient landscape, particularly through a provision lens. We'll then go on to think about some of the impacts of bioavailability and food matrix effects on the future supply of micronutrients, and we'll discuss why this needs to be an important consideration for sustainable food systems. But before I do, I'll hand over to Dr. Nick Smith, who is going to introduce the Sustainable Nutrition Initiative, or SNI as we call it.
The Sustainable Nutrition Initiative, or SNI, provides clear evidence for the sustainable food system debate. We're hosted by the Reddit Institute, a New Zealand Centre of Research Excellence at Massey University. The SNI team has expertise in human nutrition, food technology, agriculture, data science, and mathematical modelling. This expertise is used to design tools to help understand food systems, from global production and trade down to sustainable diets for individuals. For example, the Delta model is our online tool for understanding the sustainability of the global food system. It calculates what changes to things like food production, population, and food waste will do for the nutrition of the global population. The model is used in academic and industry research, policy advice, and by students at our partner universities. The SNI team can help academics, the food industry, policymakers, and government departments to better understand food systems and human nutrition. On our website, you'll find examples of our outreach and collaborations. If you're interested in being involved, please get in touch.
The Delta model was developed in September 2018, and then in the first quarter of 2019, the SNI was launched by its creators, Professor Warren McNabb, Professor Jeremy Hill, and Dr. Andrew Fletcher. So SNI is a comparatively new initiative, and one that has been rapidly gaining momentum. Warren, Andrew and Jeremy, who no doubt will be familiar faces to some of you, are supported by the rest of the team, which includes PhD students, postdocs and research officers. So as you heard from Nick, the objective of the SNI is to advocate for nutrition within diets that are globally sustainable. At SNI, we approach this using modelling on 3 scales. We have the individual level, which considers which food each of us should eat. We have the country level, which investigates the food that our country needs and how we could best use our land. And then we have the global scale model, Delta, which works towards answering the question, what food does the world need? It's important to note that Delta assumes equitable global distribution, which we know is not the case, so keep this in mind as we move forward. Sustainable food systems are a huge part of the SNI's work. Now, in 2014, the high-level panel of experts' definition of sustainable food systems can be considered to have 2 key parts. Firstly, that sustainable food systems ensure food security and nutrition for all. And secondly, that these are produced so there is no compromise to the economic, social or environmental bases involved in the generation of food security and nutrition for future generations. If we focus on the nutrition for all aspect of this definition, we can separate this into 3 broader areas of nutritional requirements. So we could go on to say that nutrition for all implies the sufficient provision of energy, macronutrients and micronutrients and trace elements. While the micronutrients are what we're going to delve into here in this talk, when we consider nutrition, it's important to remember the other factors as well, as especially in discussions around whole foods, micronutrients are just one part of a whole picture. Now, looking at the modelling of global micronutrient and trace element supply and demand, we see that in 2020, we were already short of producing enough nutritional calcium and vitamin E to meet the recommended intakes of the global population. If no changes are made to our current global food production trends, by 2030, the size of the nutrient gap grows. We also see deficiencies in other micronutrients starting to develop. This situation gets much worse by 2050. Considering that we can only operate inside planetary boundaries while feeding a growing population, it makes sense that we aim to optimise the micronutrient utilisation from the food we have. This is where it becomes more important to think about food quality, and thus bioavailability begins to play a particularly prominent role. I want you to keep this in mind as we watch this next video, which summarises some of our research on the contribution of milk to global nutrition.
How do we feed everyone in the world? With the Delta model, SNI has modelled the global food system, asking, does all of the food produced provide all of the nutrients required by all of the people in the world? But Delta does not ask the question, what should I eat as an individual? Instead, it asks the question, how do we as a global population ensure that everyone is well fed? What has SNI research found out about dairy, and does dairy play a central role in the food system and our diets? Delta modelling has shown us some startling facts. 87%, over 9 billion tonnes, of all the food produced in the world is plant. 13%, 1.5 billion tonnes of food comes from animals. At the point of consumption, around 75% of food is plant and 25% from animal sources. Milk represents about 8% of all food produced. Of all the food in the global nutrient data used in the Delta model, milk is the largest contributor to the supply of calcium, vitamin B2, fat, and the essential amino acid lysine. It is the second largest contributor to the nutrients phosphorus, potassium, vitamins B5 and B12, and the essential amino acids leucine and threonine. It is the third largest contributor to calories and protein, and the nutrients zinc, vitamin A, and the essential amino acids cysteine, histidine, methionine, and tryptophan. Of the 29 nutrients included in the Delta model, milk ranked as one of the top 5 contributors for 23 nutrients. This comes with only 7% of our dietary calories, demonstrating the nutrient density of milk. Delta modelling let us look at the waste of individual nutrients. Surprisingly, 91% of all food and nutrient waste was plant food in origin, and only a small amount of global waste was from dairy. Therefore, reducing dairy waste will not increase available nutrients very much. Trying to solve the puzzle of feeding the global population becomes nearly impossible without nutrient-dense foods like milk. But it is not the whole answer. There are nutrients that milk is not a good source of, like vitamin C. Those nutrients must come from plant foods. The global food system is plant-based, with 3/4 of food consumption from the many and diverse plant foods. But for nutritional adequacy, there is a need for our diet to be optimised with nutrient-dense, animal-source foods like milk.
As we just heard, milk is currently the main contributing food item for global calcium and vitamin B2, or riboflavin. Milk also contributes more than 10% of global nutrient availability for vitamins A, B5 and B12, as well as phosphorus and potassium. When we consider the nutritional richness of milk combined with milk's accessibility and the prevalence of milk consumption, it isn't surprising that milk has such a big role in the delivery of micronutrients to people all over the world. Milk also has a natural advantage over many of our other food sources, and that is that milk is naturally structured to be consumed by a growing mammal. Therefore, we shouldn't be surprised that milk also has a relatively high digestibility and bioavailability of micronutrients, making them readily accessible for the body. And we'll go into some examples of this shortly. It's worth including here that bioavailability is typically defined as the proportion of a nutrient that is digested, absorbed and metabolized through normal pathways. Consequently, it's not enough to know how much of a nutrient is present in a food. The more important issue is how much of that which is present is bioavailable. So it becomes important to differentiate between these two values, especially when it comes to evaluating a food for nutritional benefit or value. However, we don't just consume nutrients, we consume food. And to solve problems like sustainably feeding a growing population, we can no longer take a traditional reductionist approach, which considers only single nutrients. It's becoming increasingly clear that the impact of factors such as food structure, composition, internutrient interactions, and food or meal nutrient loadings on the bioavailability of micronutrients can't be neglected. These collectively act together to create what's called a food matrix effect. In his recent publication, Professor Tom Huppert's defined this nicely as the physiological outcome of the intake of components in the form of a specific product matrix. Or put simply, the physicochemical structure and interaction with chemical constituents, which are then followed through to physiological outcomes. The importance of bioavailability in the food matrix becomes particularly relevant if we wish to compare the physiological benefit of a micronutrient from different sources or in different forms. For example, a food fortified with calcium carbonate versus natural calcium in milk. Professor Connie Weaver recently gave a very good webinar on the complex effects of the dairy matrix on health, and I highly recommend looking that up. We won't go to quite that level of detail here, but I do want to discuss some of the food matrix effects and what this means for bioavailability. To describe the effect of nutrient interactions on micronutrient bioavailability, I want to use the classic example of calcium and the casein micelle, as calcium is a growing concern given our forecast age demographic and our rapidly increasing population. Adults are generally a negative calcium balance after their peak bone mass at around 35 years, and they go on to lose around 10 milligrams of calcium each day, although this increases by factors of up to 10 for postmenopausal women. When considering milk as an example, around 1/3 of the calcium is present in the form of soluble salts, whereas the rest interact with milk proteins and are bound to casein micelles in the form of micellar calcium phosphate. These casein micelles naturally coagulate in the stomach. As the casein coagulum is then gradually hydrolyzed, micellar calcium is released over a period of multiple hours. This has been shown to result in gradual calcium absorption, and as a result, we get fractional absorption values of 30 to 40% for a standard glass of milk that has a typical intake portion. In contrast, the release of large amounts of calcium in a short period of time will saturate the small intestinal absorption mechanisms, and this can limit absorption down to levels as low as 5%, which is seen in some supplementation scenarios. Food composition can also impact the bioavailability of micronutrients, and a good example of this is the effect of anti-nutrients. Anti-nutrients are compounds which have a negative effect on the nutritional value of food, often by blocking the absorption of some minerals, making them less bioavailable. Phytates, for example, are a phytocompound commonly found in cereals, nuts, and seeds, with oats having a particularly high concentration. Phytates are plant storage compounds, and under digestive tract conditions, they sequester dietary zinc, iron, and calcium. As humans, we lack the phytase enzyme, and so the subsequent absorption of zinc, iron, and calcium is inhibited. This means that in phytate-rich foods, like oats for example, the micronutrient content does not necessarily equate to the amount available for absorption in the human body. The example on the right was a study which used rat pups as an infant model, and these rats were fed phytate-containing solutions with added extrinsically labelled zinc. What's striking here are the decreasing levels of zinc absorption from a phytate concentration of 0.1 millimole per litre. Natural food microstructures also play a role in the determination of micronutrient bioavailability, particularly for milk. For example, mineral precipitation is typically observed in many plant-based drinks that are fortified with sparingly soluble calcium salts, for example, calcium phosphate. We don't see this effect occurring in milk because here the calcium phosphate is encapsulated in the casein micelles we saw earlier. These micelle structures thus provide the ability to transport high levels of calcium phosphate without the risk of precipitation. The graph here is from a study which showed that when soya plant-based beverages were fortified with calcium carbonate, the calcium was absorbed equally as well as when sourced from cow's milk. However, this effect was not seen if the soya milk was fortified with tricalcium phosphate. And so we see that the structure of the calcium itself is important for bioavailability. You could argue that this is also an example of both composition and nutrient interaction effects, and you wouldn't be wrong. So you see this all adds to the complexity of bioavailability. To further add to the complexity, and one more point for consideration, another aspect which impacts micronutrient bioavailability is individual variability, which includes genetic factors and nutritional status. For example, subjects with a low serum ferritin level had a higher absorption of iron when provided with fortified foods. In this example, the average relative bioavailability of iron was inversely correlated to serum ferritin levels, and so we see that the absorption of some nutrients is also regulated homeostatically by the body. As you can see, micronutrient bioavailability, and thus also the food matrix, can make significant differences to the amount of a micronutrient actually available for utilisation in the body. As such, it is important to remember that foods are more than just the sum of their parts, and micronutrient composition does not necessarily equate with nutritional benefit. The examples that we have just covered relate mostly to milk, which as a food has been relatively well researched. However, to evaluate and compare foods for their contribution to human nutrition, we must know their physiological effects. So the consideration of future micronutrient provision is complex, and there remains space for much research in the food matrix area. Just to bring this concept back to SNI's Delta model, this is an overview of the process, and the final stage of the model design incorporates bioavailability. The bioavailability data is included so we can work out the bioavailable nutrients available for consumption. At this stage, bioavailability is only incorporated for protein and the indispensable amino acids. This is because to date, there just isn't sufficient micronutrient bioavailability data for many foods, and especially not the newer foods, which includes many dairy alternatives. As a result, comparative evaluation through the model is not yet possible. Another challenge around putting bioavailability into models is that even when we do understand the bioavailability in a sufficiently broad range of foods, The targets we currently have are expressed in terms of overall intake in a diet, assuming an unquantified bioavailability that reflects that diet. Despite this, it is clear that for long-term sustainable nutritional sufficiency, our future diets must be plant-based and animal-optimised. We continue to update our models as research is released, and we look forward to sharing our next piece of research with you in the future. So, thank you for your attention, and hopefully you've taken something away today. If you have any questions or wish to reach out, please do get in contact with us. You can do that via the channels on this slide here, or if you use the QR code, it'll take you straight to our SNI website. Thank you.
Wow, thanks, Natalie. I was impressed with the data modelling from the Delta model. I guess most of us know that milk is nutrient dense, but to see that globally, milk is, one of the top 5, I think you said, contributors to 23 nutrients was, very compelling. So moving on, our final speaker today is Professor Guansheng Ma. Dr. Ma is a professor of nutrition and the chair of the Department of Nutrition and Food Hygiene in the School of Public Health in Peking University. His scientific interests are in the areas of food and nutrition policy, eating behaviour, food environment and health, and the control and prevention of childhood obesity. Dr. Ma was the Deputy Director of the National Institute for Nutrition and Food Safety, Chinese Centre for Disease Control and Prevention, from 2002 through to 2015. Dr. Ma studied medicine in China before he obtained his PhD at the Division of Human Nutrition at Wageningen University in the Netherlands. He furthered his studies in health education and health promotion at the School of Public Health at the University of North Carolina, and finished his fellowship training on behaviour and health in the Department of Social Medicine at Harvard Medical School in the US. Dr. Ma has had an extensive and diverse employment background. He has worked for the United Nations Office for Humanitarian Coordination in Iraq. He's also worked in the Department of Food Safety and Zoonoses at the World Health Organization. His work has been funded by many different organisations, including the National Nature Science Foundation, the Ministry of Science and Technology, as well as international organisations such as UNICEF, WHO and the FAO. He's published extensively and no doubt is very well placed to speak to us today about dairy in the dietary guidelines for Chinese. Thank you very much, Professor Ma.
First of all, I would like to thank the organizer for providing me this valuable opportunity for sharing the information on dairy in the Chinese dietary guidelines. I'm Guansheng Ma from School of Public Health, Peking University. We all know that dairy, a nutritious food, contains several kinds and amount of nutrients, which is essential for the survival and health of human beings. For example, 300 milliliter milk can provide about 10 grams protein, 0.36 milligrams vitamin B2, 320 milligrams calcium, and more than 500 milligrams for potassium, which will meet the need of the 15% for protein, about 30% for vitamin B2, and more than 40% for calcium, etc. However, the dairy intakes have been quite low in the diet of people living in China. The result of a series of surveys indicated that dairy intake was only 7.8 per day per capita in the year of 2000. Although it increased to about 14 grams in the year 2004 and lasted to 2009. Then it's increased in double to 27 grams in 2011 and lasted to 2018. The average dairy intake is still in a very low level in China. If we make a comparison with other countries, we can find that dairy intake in China reached only 36% of the global average and 45% of the Asian average. Therefore, the contribution of protein intake from dairy is low as well in China. The proportion of protein intake from dairy, the proportion of protein provided by dairy was about 15% in Japan, 29% in the United States, 46% in Germany, respectively. It was only 7% in China. Five possible reasons have been identified for the very low dairy intake as the following. Firstly, dairy was not a traditional food, not an essential composition like rice or Stephan bread in the diet of Chinese people. Secondly, the low production and availability in China. We can find the dairy production in China was quite low before the year of 2000 from this slide. Thirdly, the high prevalence of lactose intolerance among Chinese population. Publications indicated that the prevalence of lactose intolerance ranged from 30 to 90% among Chinese people. While the older the age, the higher the prevalence. Fourthly, food preference. A few people express that they don't like the taste of dairy. Last but not least, rumors about dairy affect the belief, attitude, and behavior of consumers, such like cow milk is a kind of food only suitable for cow, but not for human. Drink milk leads to tumors. We all know that dietary guidelines are a series of recommendations from nutrition and health authorities aimed at improving nutrition and health outcomes based on nutritional principles and tailored to the specific conditions of a particular region or countries. Dietary guideline is a food-based, not nutrient-based guideline. The development of dietary guideline is based on scientific evidence, such like systematic review and meta-analysis, etc. Dietary guideline will give priority to the most urgent nutrition and health problems. Apply balanced dietary pattern as the core idea. And take both the nutritional needs and food culture into considerations. It will focus on the sustainability of food system as well. Therefore, before the revision of the 2000 Chinese dietary guideline, the following evidence were identified. For dairy products, the relation with health, we got two conclusions. One is the dairy intake can increase bone density in children, adolescents, and postmenopausal women. dairy intake may not be associated with prostate or breast cancer. This is the source of the evidence about 53 research are included, including the relationship between cardiovascular disease, diabetes, hip fracture, bone density, metabolic comprehensive cancer, etc. The study including the RCT study, a systematic review, cohort study, meta-analysis, and the case control study. The level and evidence are at the B level, which means the evidence are relatively strong. Regarding to the yogurt, the relationship with health, we got also two conclusions. One is the yogurt intake improves lactose intolerance. Another is yogurt can relieve constipation. The evidence is also included the RCT study, before, after study, cross design study. The level of evidence are also at B level, which also means relatively strong. The recommendation for dairy were developed based on the evidence about mentioned. Regarding to the dietary guideline in China, there have been 5 versions. The first one was developed and released in 1989. Then it was revised and released in 1997, 2007, and 2016, with about 10 years frequency, while the latest one was revised and released in the year of 2022. This slide show us the covers and the number of pages of each guideline, which from a one-page poster in 1989 to a booklet in 1997, then a book with 360 pages in the year of 2022. This slide summarizes the number of items and words for each guideline. The item ranged from 6 to 10, while the number of words was from the least 40 in 1989 to the most 109 in 2007. This slide shows the items related to the recommendation for dairy and its changes in Chinese dietary guidelines. We can find that there is no any recommendation for dairy in the 1989 version. In the 1997 guideline, it was recommended eat 100 grams dairy often. Starting from 2007, the recommended amount increased to 300 grams with daily frequencies. The 300 grams recommended amount have been kept until now. In addition to the recommendations, Food Guide Pagoda have been also developed in order to demonstrate the recommendation vividly. Dairy have been in the second top of the second top in the pagoda with the recommended amount besides. Some changes have been made in the Food Guide Pagoda accordingly. A food guideline plate and a food guide abacus for Chinese children were also developed. We can find a glass of milk in the Chinese food guideline plate, and in the abacus, 500 grams milk was suggested for children aged 2 to 4 years old, while 300 to 500 grams milk for the children aged 4 to 7 years old. For the rest of the population, the recommendation is 300 grams, as I mentioned before. There are food guide pagoda for school-aged children at 3 age group. 300 grams milk are recommended accordingly. In the 2022 dietary guideline, the key recommendations for dairy as following. 1, dairy should be the important composition in the health diet for Chinese. 2, make dairy and soy products as an essential part for daily diet. 3, try different type of dairy. 4, drink milk or eat dairy equivalent to 300 milliliter liquid milk daily. This is a practical expression for the equivalent of 300 milliliter liquid milk, like 3 books of yogurt or 3 pieces of cheese are equivalent to 300 milliliter liquid milk. The market scale of dairy in industry is expanding rapidly in China. It's expected that dairy production will reach 34 million tons by the year of 2027. Along with the rapid growth of dairy production, more and more kinds of dairy products are available in the market in order to meet the need needs for taste, smell, preference, and health as well. New conceptions are also coming out for dairy products. Of course, we should realize the importance of disseminating information on dairy by using both the traditional and the new channels like newspaper, website, as well as social media like WeChat, Douyin. I believe more and more Chinese people will take more dairy in their diet. This slide shows a dairy information card our group have developed and disseminated for children. This slide shows the dairy column. We have published 17 articles with a focus on dairy nutrition. We received a lot of hits for the information sharing. I believe in the future, the dairy consumption will increase, and the benefit will, the Chinese people will get more and more dairy intake, and the benefit will be also occurred. That's all for my presentation. Thank you very much for your attention.
Thank you, Dr. Ma, for that really interesting presentation. I love the idea of a food group abacus, and I can see it working really well in an app to maybe build healthy and sustainable meals kind of across the day and see how, different meals or your diet really adds up in terms of healthiness and sustainability. So that brings us to the end of our trip around the world, exploring the role of dairy in food-based dietary guidelines and looking at the intersection between dairy guidelines and nutrition policy. It's now time for our panel discussion, and I would like to invite you all to put your questions, use the Q&A function to pose your questions, and we'll try to work through these with the panel members. So on the panel, we welcome back Dr. Sinead McCarthy, who spoke to us earlier about the balancing act of population and planetary health in dietary guidelines, particularly focusing on Europe and Ireland. And joining Sinead is Stephan Peters. I introduced Sinead earlier, but a little bit about Stephan. He obtained a Master of Science degree in Human Nutrition and Toxicology, and a PhD in the development of clinical nutrition for weight-losing cancer patients. He specialised in the translation of complex science into consumer-friendly information. Really important work, I guess, when we're talking about food-based dietary guidelines. Stephan works for the Dutch dairy industry, and prior to that worked at the Netherlands Nutrition Centre as Science and Quality Manager. In this role, he played an important role in the development of Dutch food-based dietary guidelines. Stephan currently works on the research programs focused on dairy nutrition and health and its role in healthy and sustainable diets. He is also chief editor of the Dutch Nutrition magazine and is currently the chair of the IDF Standing Committee Nutrition and Health. Thank you both. Dr. Ma, we've got you as well. Excellent. So I might kick off with a question and then I'll have time to have a look at the questions in the chat. Sinead, if we come to your presentation and maybe Stephan from commenting from a science communication lens, I think a lot about how our data consistently shows us that our dietary patterns are sort of a long way from our dietary guidelines. And these guidelines have really focused on health in the past, and more recently, they are including aspects of environmental sustainability. We see the dietary guidelines as an important avenue to promote the synergies between human and planetary health. But from a consumer perspective, are we making the messaging even more complex? Or can we see this as just different angles to speak to different consumers? Sinead, do you have any thoughts on that?
Yeah, thanks, Julie. I think that's a huge question, and I'll try and answer it as briefly as possible. I think what we have to remember, and from my perspective and what I've seen in some of our research, is that consumers aren't necessarily driven by health. So no matter how healthy, how sustainable, or whatever attribute you can assign to a food, if it doesn't taste nice, we're not going to do a repeat consumption of it. And food-based dietary guidelines or healthy eating is always promoted on that basis that it's healthy for you. But nearly half of the population eat food for the taste of it and not because it's healthy. So when you're marketing the guidelines, if you like, and saying this is very healthy, this is good for you, that's only going to really resonate with maybe about a third of the population. Whereas if you say this is really healthy, or rather this is really tasty, this is convenient, it's easy, you can bring your yogurt with you, you can pick up your apple, it's very tasty and convenient to have for lunch. We never hear the guidelines being presented in that way. It's always as healthy. So we need to maybe change the approach in how we're marketing the guidelines, if you like, and get a good PR company in all of the countries. You'll see it if you're a big food company and launching a product to market. You'll understand your consumers really well. You'll know the different segments. So I think possibly the guidelines need to be communicated to resonate with those who are maybe motivated by sustainability, and then communicate it differently to those who are motivated by health versus those who are just motivated by convenience and taste. So it makes it more accessible to the general population. And I think that applies across a lot of populations, where for the most part people are driven by taste.
Yeah, thanks, Sinead. Stephan, do you have that golden marketing campaign that's going to be the one that works for everyone?
No, you know, I have been working for 10 years on setting food-based dietary guidelines, the Dutch food-based diet, the current food-based dietary guidelines, and also in trying to make the former food-based dietary guidelines resonate among consumers. Maybe I can state it very bluntly, right? That's the easiest way, right, to make a discussion short. I do not think that food-based dietary guidelines do have an effect on consumer behavior directly. Food-based dietary guidelines, I think, do have their effect in food policies of governments, etc. And this is, of course, important because policies can indirectly have an effect on consumer behavior. For example, policies, food policies can apply price taxes based on food-based dietary guidelines, or try to steer consumers in assumptions on protein transitions, more plant-based protein transitions, and try also to influence, based on those assumptions, the food production system. But I think there's a big concern, and I think the Chinese presentation was a really good presentation, because until I think a decade ago, all food-based dietary guidelines try to base themselves on scientific consensus. And when it comes to scientific consensus, right, you can state a lot of things, the effects of products, and for example, of dairy products on non-communicable diseases, right? There's consensus about that yogurt protects against type 2 diabetes, dairy protects against colorectal cancer. And on the other side of the coin is the nutrient richness of dairy products. I'm only talking about dairy products, that makes it easier, of course. Now, unfortunately, and we've also seen that in the presentations, is that, and I really say unfortunately, we are now trying to imply also environmental aspects to food-based dietary guidelines. And what has already been shown, I cannot really recall exactly that slide, is that when it comes to food consumption and food composition, the food composition of potatoes are everywhere the same in the world. But the LCAs for products are very context specific, locally specific, and can change in time. So there, and there's not scientific consensus of applying those LCAs, because those LCAs are expressed not per nutritional value but per kilogram, applying those to food-based dietary guidelines. And here's the concern. What we see now, we all feel the necessity to change the food system towards a more environmentally food production system and more environmentally friendly diets. But a lot of uncertainties are coming into our food-based dietary guidelines on the one hand, because we feel the need to change. And if you look at the interpretation of science towards now new food-based dietary guidelines, scientists look a bit differently at the science behind the health effects of animal-based foods and plant-based foods. We are humans, right? We are all in that paradigm of eat less animal, more plant-based. What we've also seen in some slides is that when you look at, that was the first presentation, I think, when you look at the food-based dietary guidelines that have qualitative guidelines, like eat moderate amounts of dairy, then everything looks okay. But as soon as food-based dietary guidelines have calculated the nutrient adequacy of the dietary guidelines, right, resulting in quantitative advices, then we see that, for example, for dairy, when compared the guidelines to real consumption, the dairy consumption is too low. And this is, I think, a concern, and now I'm finishing my point, is that if food-based dietary guidelines do not meet nutrient requirements and hence are potentially unhealthy, you cannot call those food-based dietary guidelines sustainable guidelines, because sustainability is not only about environment, but also about health for consumers. And due to the environmental pressure on science, we tend to neglect the nutrient adequacy in food-based dietary guidelines. And I think that is we will regret that in the coming decades if this will dominate setting food-based dietary guidelines.
Sinead, did you have a comment? I saw you came off mute.
Yeah, I have two mute buttons, so I accidentally had one on and one off. But I was nodding emphatically there at what Stephan was saying. And the term sustainable needs to be is inherently healthy. So if we talk about sustainable diets, inherently we're talking about healthy diets as well. And that seems to have been divided in public discourse. And it's either healthy or it's sustainable. But sustainable does encompass, and when we go back to that FAO definition, it's a healthy, nutritious diet. And that aspect is really important. And I think it's the cultural acceptability piece. What'll work in one country won't necessarily work in another country. And as an Irish person, one of the bits I found very difficult with the Eat Lancet report was 50 grams of potatoes a day. I don't think any of them were affected by the Irish famine 150 years ago. But when you see that on your plate, it's tiny. So it's being realistic with the guidelines as well, and seeing what's culturally acceptable for one population versus another. So I think
Yeah,
that the sustainability piece is inherently healthy. So they shouldn't be separated out necessarily.
Yeah, and accepting possibly a graded kind of behavior change approach that slowly gets us from where we are, which is a long way from our dietary guidelines, and I can only speak for Australia, but miles away from the Eat Lancet recommendations. So
yeah,
it's going to take a long sort of slow step-by-step kind of approach, I guess.
And I think one of the biggest...
Oh, sorry.
One of the points I was making at the end of my presentation or at the start of it is that changing our consumption patterns may not necessarily have a huge impact, because it's the production of the food. So if ultimately our food supply is produced more efficiently, that'll reduce the carbon footprint or environmental impact of our diets as well. So supports really need to be put in place to help enhance the sustainability of the food supply itself as well.
So maybe just while you've got the microphone, Sinead, there was a question earlier asking whether you could tell us a bit more about foods that were classified as discretionary. So we all use different terms around the world, so maybe just a little bit of background for those who aren't familiar with discretionary food and beverages.
So yeah, I saw that question come in earlier, and I specifically pulled up my table to see exactly what went into each category. So when I was presenting the initial slide looking at achieving the guidelines, all of the discretionary foods were put together, and then the subsequent slide separated out beverages and the high sugar, high salt foods. So within the beverage category, there was fruit juice, tea, coffee, and water. And in some of the cases, we separated water out as well in some of the more detailed analysis. And then for the foods, it contained the high sugar snacks, high salt snacks, confectionery, desserts, carbonated sugared beverages, various miscellaneous foods, sauces and spices and some condiments. And it also included alcoholic beverages. And that's one, I suppose, the focus has been so much on animal-based foods being high in carbon footprint, and as a result, it shouldn't be in the diet. That tends to have been the kind of direction that the discourse has taken. But foods like alcoholic beverages and carbonated beverages, because they're being consumed in high amounts, although their footprint might be low, the amount that's actually they're being consumed in is generating a very high carbon footprint. So they're the two sets of discretionary foods, so the beverages and then your high sugar salt snacks.
Yeah, and just thinking about foods versus diets. So I think that's a really important point when we're adding up our nutrients or we're adding up our environmental impact. It's about the whole diet. Guansheng, I might ask you this question. Should we consider including dairy alternatives in our dietary guidelines? I know in Australia ours are a bit hit and miss. They're sort of included, but there's not a lot of information about them. What's sort of your perspective on that?
Pardon me? Could you please say that again?
I was just saying, dairy alternatives, are they something that are included in the Chinese dietary guidelines? Soy milk,
Yes,
oat-based milk.
So yeah, soy milk, soy products. As you know, in China, we have a lot of kinds of soy products. Although the nutrition, if we make a comparison with the nutrition between soy and dairy, and the soy products are not as much as nutrition as dairy, but it's still promoted in China.
Yeah, I think that's common with the plant-based alternatives to animal source foods in the meat and dairy category. They often have a different nutrient profile. And again, there's some discussion around how they should be promoted and where they should be positioned in supermarkets, for example. You know, is it creating greater confusion amongst consumers? Sticking with dietary guidelines, I guess, I'm not sure who wants to take this, but do you recommend full cream or low-fat dairy products for the general population, and thinking of that in the lens of non-communicable disease risk? Any thoughts on?
Yeah, there is some detailed information in the dietary guideline. For general population, we just recommended the whole milk. For some people with overweight and obesity or non-communicable disease, we suggested to choose the low fat content milk or non-fat milk. It depends. Yeah. And also in China, there is a lot of discussion about the sustainability and sustainable food system and the plant-based food production in recent years, as you just discussed. Yeah.
Yeah. I think there's been some work in Australia around full-fat milk in teenage boys, because some of them consume 2 liters of milk, you know, a day, and so that's when I think the fat content can be considered more. But another question here, maybe for you, Sinead, because you had data on different populations, dairy consumption relative to dietary guidelines. The question is, the various presentations shown today show that a trend of low dairy consumption worldwide. Is there any research exploring the relationship between affordability of these products? Perhaps this could contribute to low consumption, given we're seeing the rising costs of food around the world. Any thoughts on that?
I think some of the more fortified value-added products are certainly more expensive. It's not an area that I have looked into. I think it's probably more so a result of the discussions taking place about dairy's good for you, dairy's bad for you. It's changing a lot. It's coming out now as being not a sustainable product, and I think that's contributing to the lower dairy consumption as well. So it's probably making a food more affordable is always a good idea, but it wouldn't be something that I have any research data on to speak with authority about. And price is always one of the motivating factors as well for food purchases. So it will have an influence, but I think it tends to be the more fortified functional products or the value added products do charge a premium, and maybe that's something that's worth looking into.
Stephan?
Well, actually, I also wanted to respond to the whole fat, but first off, from a Dutch perspective, if we look also in the Netherlands, right, we consume a lot of dairy, and by history we drink milk, and we don't drink milk from glasses but from the package, right? That's a bit of how we consume milk. We do see, based on our food consumption surveys, a decreased intake of especially milk among dairy products. Now, there are a lot of assumptions about why is this taking place, based to the debate about health effects or plant-based products that position themselves as alternatives. What we have observed, and this is a bit of surprising, or actually very logically, milk is a drink. And if you look, especially in the Western societies, and I think also in other societies, is that young people, everybody's got their glass, their bottle of water. And we see also based on our food consumption surveys that it is not the plant-based products that position themselves as alternatives for milk, but water is the big competitor on the consumption moment where milk is normally drunk as the competitor. So it's not about the negative associations people have with milk or sustainability issues, but the consumption moment is cannibalized by the water bottles.
I guess that's, with most meal occasions, I guess we are having those healthy foods being replaced on the plate or in the drink bottle by the discretionary food category. And, meals or snacks, I guess that sometimes we think about discretionary foods as unhealthy snack foods, but I know data in Australia shows that almost half of our discretionary foods comes from in a main meal, breakfast, lunch, or dinner. So, yeah. Just thinking about those different, I guess, milk choices. I know, in Australia, people aren't necessarily one or the other. I mean, there's a growing group of the population who might have their plant-based milk alternatives out at cafes and in the home by both plant and animal-based milks. Any comment on, this sort of, we don't necessarily have to be one or the other. There's going to be some scope for, I guess, a bit of both. Are plant-based milks trendy in the Netherlands or in Ireland? At coffee shops, I mean.
Yeah, even in our work canteen, there's the jug of oat milk and there's the jug of full fat milk and the jug of low fat milk that you can make your choice when it comes to coffee break. And even standing in the queue of the usual coffee shops, you'll hear as many people ordering almond milk or oat milk with their latte or cappuccino as you will full fat or low fat milk. So it's certainly a trend that has gained traction. And I think it's providing that alternative, as you said there already, Julie. So it's not necessarily about being completely plant-based, but it's just having the choice there at the point of purchase or the point of consumption. So I think you can be both a whole milk and a plant-based milk consumer, depending on the circumstance in which you're taking it. But I think probably the biggest aspect of concern is when you look back to, say, Stephan's talk earlier there in the session, and that when he presented very nicely again the nutrient composition, looking at the plant-based burger and the beef burger, and it's not until you get down into the other compounds that aren't necessarily on the back of pack label. So it would be interesting to see a similar comparison of plant-based milks with dairy milks, and see what are the differences there. So I think there is, I think possibly that idea that this is an equal replacement for milk isn't correct. And that difference needs to be that this isn't a milk you're putting in your tea or coffee or beverage, but something else entirely. So I think it's understanding and maybe communicating that difference so that consumers are making a more informed choice as well.
Yeah, I totally agree, and I think it's more difficult when we use the word dairy alternative, I guess, because it does imply that it is a substitute for those products. I'm conscious of time, so we've only got a couple of minutes. So I just wanted to thank our panel members, Stephan, Guansheng, and Sinead, very much for answering those questions. I'm not sure I can do the symposium justice in trying to wrap up, but I guess we have heard quite a lot about the intricate relationship between dairy, food-based dietary guidelines, and sustainable nutrition policies. We heard from people about sort of that multifaceted kind of interplay, highlighting both the unique nutritional benefits of dairy foods, and really aligning our dietary recommendations with those broader sustainability goals. Consumption patterns seem to be fairly consistent, whether we look at Europe, South Africa, China, And I guess Natalie gave us a more global perspective using that Delta model approach to look at nutrient availability from milk and that. So we also, I guess, the other speakers looked at this topic more from a food production, food system perspective. So I think every time we sort of talk about nutrition sustainability and different, foods and food groups and diets in this kind of symposium, I always, just ponder on how complex nutrition research is, how complex environmental and sustainability research is. And here we are trying to put them together and really true multidisciplinary research. So yeah, I'm always just really impressed with how well working together allows us to solve these kind of global challenges. So thank you very much, everyone, for attending today and the valuable contributions of each of our speakers. It's been a really great whirlwind tour of dairy dietary guidelines and sustainable nutrition. There is a short survey at the end of the symposium, and you will receive a recording, I think, from the presentations as well, and a certificate of attendance for professional development points can also be requested as well. So just to close out, there's going to be a short video about the launch of the IDF fact sheets on the role of dairy in food-based dietary guidelines. And just, thank you all very much again for your attendance today. And I hope you've learned something and enjoyed the session. Thanks so much.
Hello, my name is Ashley Rosales, and I'm a registered dietitian and member of the International Dairy Federation, also known as IDF, and I'm from the United States. Food-based dietary guidelines are established around the world by governmental agencies and health authorities to guide evidence-based recommendations for healthy eating patterns and lifestyle choices. They form the basis for many governmental nutrition safety net programs, and they're also used for decision-making by policymakers, health professionals, food manufacturers, and many others. Food-based dietary guidelines are powerful tools for promoting nutrition security and also for overall health and well-being at the population level. Messaging within these guidelines play an important role in both national and global health efforts. These guidelines are not standardized globally, and so they can vary considerably from country to country, having implications for dairy recommendations around the world. But with the support of the action team of IDF members representing many countries and with strong nutrition and food systems expertise, we are proud to share a newly released fact sheet titled Developing Evidence-Based Food-Based Dietary Guidelines, Critical Contributions of Dairy. This fact sheet provides context and rationale for addressing the evolving recommendations surrounding dairy in global food-based dietary guidance. And it also highlights the importance of including nutrient-dense foods, and specifically dairy foods, for their numerous contributions to healthy people and thriving communities. We hope you find it useful. Thank you.